to answer question 7. Explain the enzymes and or substrates regulating the primer step, Krebs cycle, and electron transport chain. So first, our primer step, pyruvate goes to ACOA from dehydrogenase, and an increase in ATP and NADH concentrations inhibits or slows down this primer step because it's saying that the need was met and we don't need to make more ATP if there's already a high concentration of ATP. And then when we look at the Krebs cycle, the citrate synthase, ACOA plus oxaloacetate. Also, again, if there's high levels of ATP and NADH, this inhibits this enzyme because the ATP need was already met. So Krebs cycle's purpose is to make more ATP, and if there's already a high concentration of ADP and NADH, which it also makes, then it's going to be inhibited because it doesn't need more. And then isocitrate dehydrogenase and is also inhibited by the increase of ATP and NADH plus because the needs have been met. And then also alpha keto inhibited by increase of ATP and NADH plus H plus because needs of ATP have been met. And the goals for the primer step, Krebs cycle, and ECT is all to make ATP. So of course, when we look at ETC, electron transport chain, when we have an increase in NADH and FADH2, those are the main components to creating more ATP. And if those are high, it's telling ETC that, or the electron transport chain, that we don't need to make more ATP right away, so it inhibits it. So all of these steps are here to make ATP, and if there's a high concentration of ATP or the substances that create ATP, then they are inhibited. But if all of these were backwards, if there's a low concentration of ATP of any of these, then you want to activate or enhance those enzymes to make more ATP. Yeah.